thanks to all of you for sticking around until the very end. So I'm going to take down the pace a little after this balloon ride. I basically want to talk about the effort that we relatively recently started. The process is fairly slow, and it's essentially about using VR principles for training, specifically in the Southwestern region of Ohio. So we essentially got a grant that paid for the hardware to use VR for training in various different areas. And I see a lot of connections of what I've seen throughout this week. So for example, that store simulation that we developed at some point when Nate was talking about knocking stuff over. So I observed myself doing the exact same thing once we had the physics engine behind it. So I did the same, made a big mess in there, and it hit the reset button and everything was cleaned up. I would wish this worked in the real world like that, but fortunately it doesn't. So since this was funded through the state of Ohio, writing the proposal is kind of like a different style than your typical research proposal. It's more like a business proposal or proposition that you're making toward the state. And I mean, you are doing a lot of stuff in VR, so you definitely know that we've come a long way lately, particularly with all the new displays and devices that have brought down the cost significantly. If you compare this to, like, I don't know, 10, 20 years ago, that was a different story. And again, as I mentioned earlier, the idea is basically to use these kind of technologies for workforce development in various different areas, specifically in Ohio. And again, we're pitching this to the state government, so they want to essentially see that this is helping the Ohio economy. And when you look at the overall statistics, and I'm sure you know that as well, when you look at all the jobs that are available, all the job openings, there's a lot more jobs nowadays that require very specific skills. So if you come out with just your high school diploma, usually there's a lot of training that you need for the majority, for that matter, for those jobs. It doesn't necessarily mean they all need college degrees, but some specific training comes a lot, or is a requirement for a lot of those jobs. And again, that's where virtual reality, augmented reality, all of those things essentially come in, so that we, on the one hand, attract more students to those specific areas. Usually VR, as you know, is kind of like an exciting area. People are interested in that and playing around with these kind of devices and all of that. So our hope is to attract more students into our areas. Retention rate is hopefully higher as a result as well. And you can actually teach more effectively with these types of devices. There's actually studies that show that retention rates oftentimes higher. The speed of learning is increased, so we can actually churn out more people in a shorter amount of time. And if you look at the VR market specifically, there's a pretty steep growth rate that we're basically seeing. It starts a few years ago. Basically, I looked at this when we wrote the proposal initially, or started working on that. But essentially, if you look at the timing, fairly low numbers in the beginning, and then a huge ramp up, pretty much starting this year and the next few years. So there's a lot of growth potential in VR and augmented reality as well. As you can see, 93% increase for an annual rate, and that's a huge number. The job openings that we were basically targeting, this 13 or almost 14,000, that's only in our area in Ohio. So nationwide, that's certainly an even bigger number. And as I mentioned as well, benefits of using AR, VR hopefully is, and this studies that back this up, higher retention rate, more effective training as a result. Specifically, since we're focused on the Southwestern Dayton area, essentially we're targeting these 4 areas as kind of like the areas that we're essentially supporting. Aerospace is one of the biggest ones because the Air Force is sitting right next door to our campus. But as in all other areas, healthcare is a big target area. big growth area, IT, of course, and there's even still a lot of advanced manufacturing in the Dayton area, even after all the car manufacturers, for the most part, left. I collected a few testimonials that I essentially found online as well, along the lines of using VR for various different areas. The first one with Ford, they're requiring that all the vehicles that all the cars, that's how they phrase it online, will have to be tested using VR methods. So whether the buttons are in the right place and those kind of things. It's a little relative maybe with Ford in the US because they're not really selling cars anymore. The only car is the Mustang, but I assume they use the same principles for the bigger vehicles just as well. But there's other examples also. The Grill Lab, that's part of the Air Force base. They're looking into using VR for training perspectives, maintenance, those kind of things. IKEA was in the news as well for using VR for essentially furnishing your kitchen, or not furnishing, but when you design your kitchen, you can look at this in VR before it's actually put into place. I don't know if it was Tuesday or yesterday. The example of Walmart is, somebody brought that up as well, that they're using this for training purposes pretty extensively, actually. So with respect to the funding mechanism that essentially kicked this whole effort off, it's funded through the state of Ohio, specifically the Department of Higher Education, through this, they call it RAPIDS mechanism, regionally aligned priorities in delivering skills. And they split up the state of Ohio essentially in different regions. So you can essentially apply for funding for your specific region. You're supposed to essentially include some of the other universities or colleges in that effort as well. So that's essentially funding-wise what we're looking at, and it's only dedicated for hardware, and they're not paying us for developing anything at this point. That's the next step that we have to apply for funding for those kind of areas. But specifically in terms of hardware, what we're looking at is essentially a four-sided cave display, because our current one, it's kind of on the way out. Two of the projectors are basically dead. So we'll have to definitely replace that. So we're in the process of doing that. We're looking at HR devices, probably the Magic Leap, also some HTC Vive displays. Some of the other colleges have additional equipment as well. So for example, one bought a welding trainer, so you can actually use virtual reality to practice welding before you actually destroy and burn stuff up and those kind of things. And as far as the target areas that we already got essentially buy-in from, I expect this list to grow quite a bit once we actually kick this whole off. So of course, I'm with computer science and engineering, so they're involved from all the software side and those kind of things. Electrical and mechanical engineering is on board. We work already quite a bit with nursing, medical school that's interested. We have people from architecture and as well as manufacturing. Like I said, this is probably going to grow from there. So since we haven't purchased all of the equipment yet, so we're essentially in the process. This is a painstakingly slow process actually, because everything we buy has to get approved from the state government, even though the whole project was already approved. But I want to give you a little bit of an overview of essentially what's already available and what are all the devices that we're essentially tinkering around and testing things with. So we started with smaller scale display devices. So you see just essentially a big screen TV. This is the second one. The first one essentially walked off. Somebody actually stole it from the lab. So this is the replacement. Yeah, this was kind of annoying because they, you see the tracking device, in this case, the OptiTrack Duo. We had an OptiTrack Trio attached to the TV, and they took that with them. But all was left then essentially was the power supply and the equipment I can't do anything with. So it's a big investment that they can't do anything with either, now that they have it in their possession. But anyways, I'm getting off topic. Oops. That's another display that I built essentially with low cost in mind, just a standard passive projection screen that is stereo capable. You see my little mount that I essentially built myself. It's just a bunch of threaded rods and a few pieces of wood that the projectors sit on. Probably not too easy to see the polarization filters in front of them. We use the Kinect tracking system, the Kinect as for the head tracking, so it actually works reasonably well, relatively low cost. Another device, we played around with tile displays quite a bit. This is essentially the second generation that I built. It's in this case it's 6 4K TVs. So pretty decent resolution, all driven by one computer. You saw this earlier, yesterday probably. It's relatively easy to drive as it's just essentially one desktop, or to use, I should say, one desktop that you can play around with it. You see the older generation on the right side that I'm kind of blocking off. That's essentially slightly less resolution with 20 monitors. So driving that with a single computer is quite a bit more involved than driving 6 displays with a single computer. You see the computer kind of here down at the bottom. It's probably hard to see, but when you look at all the wiring coming out of it to connect up to all those monitors, it's kind of like a little bit of an interesting build anyways. And so we scaled this up to essentially higher end or larger displays. So this is kind of like a cave-ish environment that I built myself. It's essentially 3D capable TVs that use active stereo, has a 12 by 12 footprint. So it's a similar style in traditional caves. Use the OptiTrack natural point for the tracking, the optical tracking system. Essentially has all the traditional kind of cave-ish features. Of course, it doesn't have a floor because I can't walk on TVs, so it's only the sides. With respect to footprint, this is just essentially the 80-20 aluminum framing. That's the sketch they provided me with when we purchased this. Gives you a little bit of an idea of how big this whole setup is. And driving this, because it's built out of a 3x3 grid of TVs to cover the whole range. Of course, driving it is a little more complicated because now you're looking, if you stick with the usual or conventional setup with a master node that's hooked up to the tracking computer to get the feedback or the tracking information on the tracking system. And then the slave computers, of course, now have to drive these 9 monitors or TVs. So those look a little more complex from that perspective. I have another image that shows you the guts of the computer that drives a single wall. So it's essentially at the top, the sync card for the active stereo synchronization, and then the 3 other red boards are basically the graphics card that where 3 of the TVs, essentially 1 column, is hooked up to a single graphics card to drive the whole system. And then the other images show you essentially like the gamepad that we use for essentially its input device, and of course the glasses. I built a little glove type device as well. So what you see on there, it used to be a wireless mouse that I just essentially rewired to get the contact mechanism from. So that was a pretty easy build. The other interesting thing is the glasses have, if you look at the antennas for the reflective spheres, it seemed to work a lot better with rods that actually extend out a little further, less occlusion basically. So the tracking system was much happier with that kind of configuration. Other devices that we play around with are head-mounted displays, and I have my oldest one, this picture. Of course, we can use Oculus Rift, HTC Vive, or we have a HP mixed reality device as well to play around with. So we can certainly use that. You see the backside actually of the system I was talking about earlier. So it's actually fairly clean with the 80-20 aluminum and all the wiring. As far as the software is concerned, we do use Unity as well, but we also use other frameworks. You saw graphics card wise, most of the time I use NVIDIA graphics cards. The drivers seem to be better. At least I have better experience with those. The dive system with the 27 monitors, I did switch to or purchased ATI cards. And this, the simplest, the only reason for that was that it was cheaper. Essentially, at the time when I built the system, NVIDIA allowed you to only connect 2 monitors per card, whereas ATI has 4 outlets and you could use all of them. And then the sync cards from NVIDIA only allow you to connect 2 graphics cards to 1 sync card. And ATI lets you connect 4. So with the 3 cards, I'd have to only use 1 sync card, only 3 cards. NVIDIA, I would have to go to, I don't know, 5 or something like that to cover the whole wall. So the price goes up quite a bit. The downside with ATI that I learned is essentially the driver support. It's not that great. Initially, the frame locking didn't work at all in my setup. Essentially, I guess it was a little beyond of what they expected. So I had some back and forth because I'm using Linux, and at the time I used Megaya, which was unsupported by ATI. And so they essentially just told me, yeah, you're out of luck. There's nothing we can do. And by the time I told them whether I should return the $10,000 in graphics hardware, they said, oh, maybe we do something. So they actually sent a field engineer out to take a look and confirm that I did everything right. It was just that driver. And shortly after, they did fix it. So that certainly helped. But the driver now for those cards, it reached the end of the lifetime. So there's actually no support for those cards anymore on the Linux side. So I actually had to switch to the open source drivers. It's not necessarily what I wanted to do in the first place. Anyways. Other software component, the Wrapup framework, I'm pretty happy with because it works fairly universally across all the displays. So that helps a lot. Tracking systems, you saw some examples. We use Natural Point, Connect system using the FAST software. We use ART for our case system. So we have pretty good experience with actually all of those. A few more words with software. Again, the viewer, the Wrapup library basically allows us to support all these displays without even changing the software, which is nice for students. We have another lab where students can essentially develop stuff. They have also optical tracking systems in there, but then they can go into the bigger labs and just run their software. Interesting piece here, you see there's a reason why I have these 2 display systems show essentially the same thing side by side. It's something we worked on relatively recently. So these are actually completely synced up. So if I change, for example, to a different time step on one display, the other one actually switches to, and you can have other systems like a laptop computer, for example, to the whole framework. And if it's connected to the same server, it'll all essentially be synced up nicely. So it actually works pretty well. Since we're using the Wrapup library, of course, there's freely available software that readily works, like Oliver Krylos, this VR Photoshop as one example. I'm not even going to try and pronounce what that volume render is supposed to be pronounced as. Thank you. We built our own framework based on Wrapup using VTK so that we can use all the libraries or all the algorithms in VTK. So you see a volume rendering. So that gives you nice quality rendering. And again, supports all the displays that I talked about. So that's pretty nice there. And it's a lot easier now that VTK supports rendering to an existing OpenGL context. When I started this, they did not. So that was a lot more hacky than it is now. So that actually helped quite a bit. There's other frameworks that we incorporated into the Wrapup framework. For example, OpenSceneGraph works pretty well. Here you see same image that I showed earlier. Essentially an OSG Earth plugin for OpenSceneGraph that just downloads all the data directly from OpenStreetMaps as you fly. So if you zoom in, it gets essentially all the updated information. So it's kind of neat. And of course, you can overlay that with additional information. A few more examples of applications. This is the framework I mentioned earlier. The dive display, I tried to install Unity on it, but since it's using 9 displays hooked up to one computer, it basically just crashes because Unity only supports up to 8 displays. So that's unfortunate. So we had to essentially come up with our own framework. In this case, as I mentioned earlier, it's based on Open Scene Graph. We have a physics engine tied to it, so we can essentially toss things around. And then we started to work with human factors and psychology. And so you saw the nice grocery store simulation that we had earlier. So they wanted to essentially look at it from a visibility perspective. And so we had all these nice shelves everywhere stocked with all sorts of stuff. And then they said, can't you make this simpler? We want to have essentially less distractors and all of that. So that's essentially what we ended up with. From a graphics perspective, it's as boring as it can get because it's essentially just a couple of blocks, but that's what they were after. So essentially a relatively random pattern with the grayscale that you can see. And I don't think there's any markers on there. There's on some of those spots, there's specific markers on there that people were supposed to find as they walk through the environment. And essentially that's what they were after. Another example that was interesting because it used these displays from a somewhat different perspective. So it's essentially a comparative visualization for molecular structures, protein models essentially. And they wanted to see which of those proteins are actually the model that that actually reflects the geometric structure. And so they had usually multiple candidates, and they exposed these proteins to different chemicals to see basically what they reacted with. And so that essentially allows them to rule out certain configurations. So if the reactive site isn't exposed, but it reacts, then obviously that can't be the model behind it. And so here we were able to show them 27 proteins at the same time, because that's how many monitors we have. And of course we could technically increase that number if necessary. But from a user interaction, it was interesting because, as you can see, my student up there, because we have all the head tracking information. So in this case, when you do the view manipulation to rotate the protein and all these things, zoom in and all that, it was actually dependent on which one you actually looked at the time. So you look at one protein, you rotate it, and then you look at another one, and then all of a sudden that starts to rotate. So that made it a pretty interesting, interesting user perspective. This slide essentially shows a few more examples of, this is the dragonfly I showed earlier in one of the side-by-side view. Was an interesting project where we essentially reconstructed the geometry based on high-speed camera feeds that we captured the dragonfly as it took off with, and then reconstructed the geometry and then fed that into a CFD simulation to actually get the vector data. And at the bottom, you can actually see that being visualized in the cave. The other ones are well, coordinate plot, fairly complex data set. Right below that, interesting, kind of like an AR-ish application where you have a subject matter expert that basically gives you instructions on your tablet as you're performing specific tasks. It's it's a little older data set that we played around with. It's a arterial model of, in this case, a pig heart. The beauty behind this is that it's very detailed. So it goes all the way from the proximal vessels all the way down to the capillaries. It's actually a huge model, which is kind of challenging to visualize, especially in these virtual reality kind of environments. On the right side, you see me in the cave actually with that same data. It's not as fast as I would like it to, but it's workable from that perspective. We can tie into a somewhat supercomputer-ish system. It's an older system that the Air Force retired, and we basically inherited it from there. So we can, thanks. We can directly tie into that to do various simulations and even high performance, using the high performance computer to essentially prepare visualizations that we can then throw onto our displays. One thing I definitely wanted to mention too is the input styles. I showed you the gamepad before. We have different gloves and of course the head tracking. The one part I do like a lot, maybe not necessarily for the cave itself, but for the larger displays, the tile displays, is that touchpad that you see down at the bottom. So the touch input actually works, personally at least I like it a lot, where you can have the same style input mechanisms that you know from your phone, like the pinch zoom, the rotation with your fingers and all of those things. But now it actually translates onto the bigger display. So makes for a pretty intuitive input paradigm with those kind of, even the bigger displays essentially. So we wrote essentially a driver or plugin or whatever you want to call it for Rui to essentially support different kind of touch-based input paradigms. The touchpad, it's nice because it's mobile, it's wireless, charges us through USB, and then you can just carry it around and do all your view manipulations and input. But of course, you can also use bigger touch screens themselves, so that's actually nice. In this case, I kind of tied the larger display together with this. It works nice for showing things to a larger audience. The smallest screen on the right side, I can essentially drive it through that, and that's fully touch capable, 10-finger touch input essentially. And I can do all the view manipulations and then explain things to wherever I'm talking to. So it makes a pretty nice interface for that. So we can throw CT scans, for example, on there, and it works pretty well for that. I really like it from there. I have other examples for applications that I'm just gonna probably skip in the interest of time. So basically, as far as the conclusion is concerned, I think there's a lot of technology available that we can tap into, and we're probably gonna grow it from there, particularly with the educational component in mind. So as I mentioned at the very beginning, I expect the application areas to grow over time quite a bit. I mean, the growth trajectory is probably just limited by my time and the workforce that we can afford to essentially put into. But there's already quite a few things or follow-on project that kind of like started to roll a little bit. So I think overall the impact is going to be quite significant. So I'm definitely looking forward to doing more in this area, and well, maybe next year I have more to report and show you actual results. And with that, I'm open to questions.
Awesome, thank you, Thomas. I'll start the question off. Have you been sharing your code back to Oliver for your Rui modifications?
I have not. I should. Yeah. I mean, it's just a tool that you can just plug in readily into anything. Okay. It's pretty easy.
Okay.
You showed the supercomputer-ish thing as a back resource. How does that talk to the display? Does it talk to the display at all, or do you just prepare things before showing on the display?
Depends on what we're trying to do. Like the one example I showed you, like this parallel coordinate plot, that's something we can actually calculate on there and then transfer over. So it allowed us to actually support larger data sets. It was actually integrated into the work with the Air Force. It was integrated into their workflow so that any data set that they calculated on the supercomputer, they could readily display using our algorithms.
But does it do calculations based on input at the visualization front end? Or
yes, it does.
How do they talk to each other?
I mean, it's basically over the network. All the UI elements are on your local machine. And
no, I mean more protocol. Is it Unity or what kind of software are you
running? No, we based it on, it's essentially a build on D3, the D3 library.
I have a question about, you mentioned something earlier that the grant that you were submitting, the $900,000 was for hardware only.
Yes.
And then later funding would provide the human resources necessary. Can you go describe describe a little bit of the challenges or the you know, how perhaps the hardware is easy to fund because it's big, it's fun and shiny versus the people that are needed to run the technology.
Yep, that's definitely one of the big issues. So the state of Ohio essentially, like you said, gives you just the hardware money, and technically they expect you to be ready to go once the hardware is in place. So we probably started with a lot of open source type projects and stuff we already built. And then we have to buy follow-up grants to the usual suspects to get essentially the human resource part covered. But we're working on that part.
I just have a suggestion, Thomas. So if you have to revisit images, Unreal has a thing called end displays. Have you seen this? No. Okay, so it's just meant for distributed multi-display rendering. They use it for concert productions that are real time, but it seems to be performing.
Definitely something to look into. Thanks.
Okay, thank you, Thomas. If there's no other questions, so I don't know if any of you, okay, yeah, go ahead. Applaud for Thomas, please.